All right, we're going to talk about angle of elevation and angle of depression. So the angle of elevation is the angle between a horizontal line from an observer and their line of sight to the object above them. So here's your angle of elevation. An angle of depression is the angle measured downward from the horizontal line of sight to an object that is below the observer. So here's your angle of depression. So it's not this angle ever, it's this one up here. You've got to have that horizontal line and then the angle down to the object, or angle of elevation. Again, horizontal line of sight up to the object you're looking at. So for each of these problems, we're going to draw a picture, set up a trigonometric equation, and solve. Number 1, the wind speed affects the angle at which a kite flies. The table shows the angle the kite line makes with a line parallel to the ground for several different wind speeds. You are flying a kite 4 feet above the ground and are using 5,000 feet of line. At what altitude is the kite flying if wind speed is 35 miles per hour? So here's my little right triangle. Here's my angle of depression, because they said that the kite makes with a line parallel to the ground. So the angle at 35 miles per hour, since that's what the wind speed currently is 48 degrees. So this angle of depression here is 48 degrees. We're using 500 feet of line. And then we also have to take into account we are standing at 4 feet. So eventually we're going to have to add on 4 feet. But we need to know, what is this? How high is it from the top, from our 4 feet up to where the kite is? So we could use sine, since we're looking for the opposite side and we have the hypotenuse. So we'll set up our trig ratio. The sine of 48 degrees will equal x over 500. So 500 times the sine of 48 degrees equals x. And so now we need our calculator. So we'll do 500 sine 48. So we have x is approximately 371.6 if we round, or let's keep the hundredths place actually, let's round to the hundreds. So we'll do 57 hundredths. But then we also have to add on our 4 feet. So total altitude if we add 4 to that, we will get 375.57 feet high. So that's how high the kite would be. All right, the next one. An airplane flying at an altitude of 30,000 feet is headed towards an airport. To guide the airplane to a safe landing, the airport's landing system sends radar signals from the runway to the airplane at a 10-degree angle of elevation. So here's our angle of elevation, so 10 degrees. So we know it's flying at 30,000 feet. So here's gonna be my super rough looking airplane flying towards the airport. It's flying at 30,000 feet, angle of elevation. So that means from the horizontal sight line up to the plane is 10 degrees. And so we're asked for how far is the airplane measured from the ground from the airport runway. So we're looking for this distance right here. And so I'm going to say that the tangent, since I have opposite and I'm looking for adjacent, of 10 degrees will equal 30,000 divided by x. So then we multiply by x and divide by the tangent to see that x would equal 30,000 divided by the tangent of 10 degrees. And again, we gotta always make sure our calculator's in degree mode when we type these things in. So remember, mode is next to the blue second button. Always check there to make sure that says degree, and then second mode will quit you out. But so we've got 30,000 divided by tangent of 10 degrees. And so we get approximately 170,138.45 feet away from the runway. If we want to know what that is in terms of miles, reminder that there are 5,280 feet per mile. So we could take the number we got and divide by 5,280 and see that that's approximately 32.2 miles from the airport runway. All right, number 3, to an observer on a cliff 360 meters above sea level, the angle of depression of a ship is 280 degrees. It's 28 degrees. So, let's say here's the cliff. So we've got this triangle here, but the angle of depression is what they're telling us. So this angle up here is 28 degrees. It's always got to be to the horizontal line. So it's never going to be this angle in here. It's got to be this one up here with the horizontal line. And so we're looking for the horizontal distance between the ship and the observer. So the observer is 360 meters above sea level. We can use alternate interior angles to know that this one is also going to be 28 degrees. And we're looking for this distance here. So we could do tangent again since we have opposite and we're looking for adjacent. So the tangent of 28 degrees has to equal 360 divided by x. So again, we'd multiply by x and then divide by the tangent. So 360 divided by the tangent of 28. And we would get 677.06 meters. So the horizontal distance between the ship and the observer would be 677.06 meters. On to the next one. Oops. So an airplane over the Pacific sights an atoll at an 8-degree angle of depression. If the plane is 550 meters above the water, how many kilometers is it from a point above the atoll? The definition of atoll is singular groups of coral islets that is synonymous with a lagoon island. All right, so we will try to draw another airplane here. I'm clearly not very good at drawing airplanes, but pretend that's an airplane. It's flying over the Pacific, and so its angle of depression with this atoll, so this circular group of coral islets. So we're just going to pretend here's an island. So this angle of depression here is 8 degrees. So that means this one down here would also be 8 degrees by alternate interior angles. The plane is 550 meters above the water. And we're looking for how many kilometers it is from the point above the atoll. So we're looking for this distance here. If we would take this point, we're looking for that distance, whichever way you want to think of it. We know the opposite side. We're looking for the adjacent side. So again, tangent is a good choice here. So the tangent of the 8 degrees is equal to the opposite side over the adjacent side. So to solve for x, I would multiply by x and then divide by the tangent of 8 to get the x by itself. And I would get 3,913 and 45 hundredths kilometers. On to the next page. So number 5, you must order a new rope for the flagpole. To find out what length of rope is needed, you observe that the pole casts a shadow 11.6 meters long on the ground. The angle of elevation of the sun is 36 degrees in 50 minutes. How tall is the flagpole? All right, so we've got our flagpole here. It casts a shadow 11.6 meters long on the ground. And the angle of elevation of the sun here's our sun. So our angle of elevation up to the sun is 36 degrees and 50 minutes. So let's first turn that into straight degrees. So we'll do 36 plus 50 divided by 60 to go from the minutes to just pure degrees. And so we'll get 36.83 repeating. And that goes here. And they want to know how tall is the flagpole. So we want to know this here. So again, tangent is our best option here. So tangent of 36.83 degrees has to equal opposite over adjacent. And so we'll multiply by the 11.6 to get the x by itself. And so we'll see that the flagpole is approximately 8.69 meters tall. All right, number 6, a statue of the town's founder stands in the town park. Nicholas is 14 meters from the statue. So here's Nicholas, he's 14 meters from the statue. The angle of elevation for Nicholas to see the top of the statue is 31 degrees. So here's this big statue. He's looking at the top of it, so let me shrink it down a little bit. Nicholas's eyes are 1.5 meters above the ground, so eventually we're going to have to add on 1.5 meters. And so we're looking for this. How tall is the statue? So we will say tangent of 31 degrees equals opposite over adjacent. So we'll multiply by the 14 to get x by itself. And we will get 8.41. But then we also have to add on to that the 1.5 meters that his eyes are above the ground. And we figure out that the statue is approximately 9.91 meters tall. All right, number 7. A ramp is being built to access a door that is 1.5 feet above the ground. So here's my door. Again, 1.5 feet to the ground, and our ramp is being built up to that door. So here's my ramp. Find the length of the ramp if the angle of elevation must be 8 degrees. So again, tangent, good choice here. So tangent of 8 degrees equals the 1.5 over the length of the ramp. So then we'll multiply. You know, when workers are designing ramps, these are things they have to take into account, is that level or angle, I should say, of elevation that they're allowed for the ramp, the grade, how steep it's allowed to be, the distance, how long then they need to make the ramp to ensure that they only have that angle. That's how they do it. And so we'll get 10.67 feet is how long they would have to make that ramp to make sure. I just solved for the wrong thing. Let's think about that again. That would be the horizontal distance, but what we actually need is the length of the ramp. So I actually need to find this over here. So let's try that again. We need the hypotenuse if we want the actual length of the ramp. We have the horizontal distance that we would need for the ramp to exist in, but they asked for the actual length of the ramp itself. So let's find that. For that one, I should use sine. So the sine of 8 degrees would equal 1.5, the opposite side, over the hypotenuse, which would be the actual length of the ramp. And so we'd multiply by y and then divide by the sine of 8. So we get 10.78 feet for the actual length of the ramp itself. So the ramp itself will be 10.78 feet long. All right, number 8. A man is standing 85 meters from the base of a tower. So here's our tower. The man is standing 85 meters from it. If the tower is 200 meters tall, find the angle of elevation from the ground where the man is standing to the top of the tower. All right, we have opposite and adjacent, so we will use tangent. So the tangent of this unknown angle will equal the 200 divided by 85. And so to solve for the angle and undo the tangent, remember we need to use the inverse of tangent. And to do that on our calculator, we have to press second tangent. So we'll press that blue second button and the tangent button. Right above tangent in blue, you see tan to the negative first. Remember that this is the notation for inverse. So inverse tangent of 200 divided by 85 tells us that the angle must be approximately 66.97 degrees because we're in degree mode in our calculator, so it gave it to us in degrees. And that would be our angle of elevation there. All right, one last problem here. A scuba diver spots a shipwreck at an angle of depression of 26 degrees. So here's my scuba diver with his pack on. And so his angle of depression down to the shipwreck is 26 degrees. The angle of elevation from the scuba diver up to his boat is 53 degrees. I did not leave myself enough room, so let me shrink that down. Okay, so then angle of elevation up to his boat, so this one is 53 degrees. So up here is his ship to take him home. If the shipwreck is located directly below his boat and the horizontal distance between the scuba diver and shipwreck is 120 feet, find the vertical distance between the shipwreck and the boat. All right, so I need to know this distance, and then we'll add them up to get the total distance between his boat and the shipwreck. So first, if I start with x, that vertical distance between him and the shipwreck, I will do tangent of 26 degrees equals opposite over adjacent. So I'll have to do 120 times the tangent of 26 degrees. And I'll get 58.53 for x. For y, I will need to do the tangent of 53 degrees, and that will equal y over 120. So I'll have to do 120 times the tangent of 53 degrees. And so I'll get 159.25. So if I add those up, 58.53 plus the 159.25. So if I add those two together, oops. We get 217.78 feet between his ship and the shipwreck. All right, so the key for these problems is to draw yourself a picture. Even if you are not a talented artist like myself, just do your best. Just get yourself in a little picture of what's going on. Draw in your triangle, think about what you have, and then which trig ratio will allow you to solve for what you need. Set up your trig equation and solve.